Okay, we're going to talk about domain and range. And today we're going to talk about domain and range in terms of both number sets and graphs. So in this first one, I want to just remind you that domain is all the possible values for x. And range is all the possible values for y. So with that in mind, let's look at this first example. So the number of buses x can hold y students. Determine the domain and range. So x is our domain, and therefore our domain in this case is going to be the number of buses. So if I'm listing my domain is any number that I see in the buses row. So I am going to put down 0 because I see a 0. I'm only going to put down 1, 1 because whether I put down 1, 1 or 2 1s, it doesn't matter. 1 is still 1. Same thing with 2. So 0, 1, 2, and 3. So that's my domain set for this problem. Range, remember, says it's the y values. So we're talking here about the students. So in this table, the students are the bottom row. So I'm going to do that. 0, 12, 40, 50, 56, 81, and 100. Notice that in both of these, I have them written in numerical order. And again, in the domain, I did not repeat any x's. So let's look at this next one that's a little bit more straightforward. Doesn't talk about real world situations here. So it says to determine the domain and range. So I'm looking at this set of ordered pairs, and I'm going to pick out the x values in order to do domain. So the x values in here are 4, -2, 3, and 0. Remember I said up here I need them in numerical order with no repeats. So numerical order means my smallest one is -2, then I've got 0, then I've got 3, and 4. For range, I'm going to look at my y values in each ordered pair. And again, I'm going to write them in numerical order. So my smallest y is a 3. Then I've got a 4, a 6, and a 9. So there you go. I just told you and showed you how to find domain and range of a set of ordered pairs. Where it gets a little trickier is when we start to take into account graphs. So here I have two graphs for us. One is just a line segment with a closed and an open circle. One is a parabola. So we're going to look at the parabola first. Remember, domain is possible values for x. So if I look at this graph, it's got arrows that go up and out, up and out. And so because it goes up and out, we know that the domain here, can go as far negative as I want. It might take a really long time to get to -100, but it will eventually get there. Same thing on the other side of the domain. So it can be as positive as I want it to be. Again, it could take forever to get out to 100, but it will eventually get there. So because this domain covers the entire line, the entire length, we're going to say that this domain is all real numbers. I like to use the symbol for real numbers, which is R, but you could write out all reals if you would like. Another way to write this is negative infinity to positive infinity. It's another way to write it. Okay, so let's look at the range here. So the range, again, is the y value. So looking at the y value, I've got arrows that point up. That means it can be any number way up there into the highest heavens. But when I look at down, I notice that my parabola stops. So because there aren't any points underneath that vertex of that parabola, we're going to go down to that point and we're going to stop. So if it goes up and up and up forever, but has an end point, that's going to be an inequality. So the y has to be greater than or equal to, because it's above that number. And then what's the lowest number? -3. Okay, so looking at something more like a line segment, with a line segment, it's the same idea. Okay, so how far negative can I go? I can only go to -3, right? My graph has an endpoint at -3. And it's a closed endpoint, so I'm just going to color that circle in so that I know. As far as positive, how far positive does it go? It goes only to 2, and it's an open circle on 2. So we're going to write it with an open circle. Now, way back, we talked about compound inequalities, and that's how we're going to write this domain. Okay, we're going to write our smallest number, -3. Our inequality sign's always open to the right. Our x, because we're talking about domain, and then our biggest endpoint, which is 2. Now I go back and I check to see if these are filled in or not. So my my smallest endpoint is filled in. That means I need a line underneath that inequality sign in order to make it filled in. My biggest endpoint is not, so I can leave it as is. Looking at the range, I can only go down to -2. It is a filled in circle, so I'm going to fill it in here. And if I go up, I can only go up to, looks like 4. So again, it's another line segment, which means it's going to look like a compound inequality. I'm going to write my smallest endpoint, -2, opening to the right with a y this time because we're talking about range, and our biggest endpoint, which is 4. Which one of those circles is filled in? The smaller one is filled in, the bigger one is not, so I have my line underneath the smaller one. All right, hopefully that kind of opened your eyes a little bit to some domain and range problems.